Yeah, thank you very much for this opportunity to present city climate to the TNT conference. This is an applied IoT project, and I'll try to walk you through some of the key steps and outcomes of this project, which started in Switzerland. The reason for doing city climate projects and technology is a combination of the realization that our climate is warming, as you can see on this extrapolation of current state towards the future, with temperatures rising something about between 2 and, in the worst case, more than 4 degrees towards the end of the century. And this will affect mostly cities, because cities by their nature do already have warmer temperatures in their cluster of buildings and urban agglomeration than surrounding areas. So the impact is likely going to be higher on in those areas. Plus, there's more than 50% of the human population by now living in such cities. The other reason which sort of tempted or triggered us to get into this city climate project as a weather service was that we see a change of technology. And in this slide, you see a range of components which are necessary for such a system, such as measurement stations, placement in a city, data connectivity, data management, interface supply. So you can see those data, which we would describe as the minimum viable product, and then you would add forecast and city maps to that, so people can orient themselves in the city as additions to such a system. And if you look towards the past 10 years, you would find that typical weather stations weigh 5 to 10 kilos. There's even heavier monsters of that type. Planning is manual. Installation is, of course, manual. GSM or Wi-Fi are the standards for connectivity, and the best standards. You have classical database standard formats and a relatively high error of forecasting such situations in a city environment. And some, of course, map generation, which is based on GIS systems. And looking forward, you can see that many of these system components have evolved. They have made technology leaps, if you like, with very nice weather sensors now accommodating 3 to 5 precision sensors in less than 1 kilo, with GIS-based solutions allowing very clever deployment in cities. LoRa, NB-IoT, enabling very cheap and easy setup transmissions, and high-performance databases allowing people to manage such services in a more clever way. And last but not least, we have better precision forecasting systems plus satellite images, which allow us to interpolate measurements very easily throughout larger areas with quite a high resolution. So we're essentially moving from a research to an online capability in city climate monitoring. So what we set out to do in this project was populating Zurich, in this case with weather sensors, and we've done that 2019 and already saw some surprising or larger than expected differences. Temperatures on left-hand side on a summer evening ranging from 23.7 to something like 33 degrees, and here on the railroad track sides, precipitations ranging from 4 or 6 millimeters in this slide somewhere here in the bottom to more than 40 in some instances here in the upper cluster. And of course also data management issues. If you look at these 2 zeros, sometimes some sensors don't send data. So in addition to detection, you need to also do a lot of data management. Anyway, so taking those measurements and coupling them with satellite maps, we can start detecting sort of so-called local climate zones in cities. And this map gives you a hint on the differences which we can detect. And then we can map the measurements onto those different zones and extrapolate one measurement towards the surrounding. And using some other interpolation methods such as altitude, NDVI, albedo, sky view factors, we can produce maps which then essentially reflect the temperatures on any given square meter or 10 square meters, depending on how you do, interpolate based on these measurements towards the entire surrounding. That produces a very nice map, which has very nice colors, but in the end of the day, what matters are not the colors, but the precision. So what we did, we compared each of these interpolations to a respective station by using half of the stations for generating the model and half of the stations for then controlling the quality of the output. And this is what you see in this chart. Here on the bottom axis, you see the number of stations used for training the model. And on this other side, you see the respective number of stations used then for, the other way around, for testing, and here for training the model. So what you see is if we start to use something like 45 stations for training and 45 stations for validation, we will get to precisions of the temperature interpolation for every sort of given square meter, which are below 1 degree centigrade, which is pretty good because that's less than the difference you have between your balcony and your front door usually. And so, in looking at the right-hand schema, you will see that those differences during nighttime are even smaller. The errors which we detect with 15 stations, we already get close to 1 degree centigrade error. If we use 60 stations for the training, we get to errors which tend to be mostly below 1 degree, and sometimes during daytime they hop a little bit higher, but then go down again over the nighttime. So essentially, we're saying that with these validation, with these stations, we can build a data set which essentially measures every piece of the city, every doorstep, every balcony, every parking lot, every park bench, etc. So with that system on the background, we can now think about generating services for people involved, such as giving people an idea on what the temperatures did in their particular location over the past day, or creating forecasts for that location for the next couple of days. And these should be so precise that people can effectively orient their behavior or even select preferred areas in a city based on such forecasts. So this is kind of a new approach. The difference to the current approaches is that we didn't have access to such station measurements, and now we can easily, using IoT and modern miniature sensors, to develop such or implement such own networks. We can calibrate those stations easily to existing weather networks, precision networks. We can do quality control in-house, which is before kind of an issue or not very clear. And using the satellite maps, we do advanced interpolations which reflect the individual city structures. Plus, using satellite for background mapping and artificial intelligence, we achieve errors in the interpolation which are below 1 degree centigrade on an hourly basis. And we think we will be able to scale such systems to precipitation and winds and others as well. In summary, we're seeing step change approach to city climate, which we believe is going to enable us to really tell people what is going on and to make them feel that what the data they're getting is really what they're experiencing. Well, what does it take to run such a system? It takes these elements I already mentioned, and the typical approach to implementing such systems with current technology will take something between 2 to 3 months, in the best case up to, let's say, a year if we do this in a more elaborate stepwise way. But those are timelines which we can think of city administrators or planners or operators being easy to handle on a practical operational level. So in summary, what did we learn? We learned that there is an option for an online service in this new segment, city climate, after 1 year of experience in 2 cities. We have temperature and precipitation differences which are larger than expected, so there's something to manage in city environments which can now be detected and explained. We have developed data management systems which catch errors and manage the huge data volumes, and we can map those to the city individual structures quite nicely. Precisions are good, and we have prototypes for those ready in 2020, which we want to start taking to other places so we can confirm the results. So there's a lot still to be discovered, of course. Heat in humans, what does that really do to us? Airflows in cities, emissions, mitigation strategies. So this is not the end. This is probably just the start of a new chapter of meteorology. So IoT and such systems will enable us to better manage our cities for the future. And we hope that this is going to make a change for climate change. In that sense, thank you very much for listening, and hope that you'll join us on this mission in the future.